In this video, we will be discussing linear equations in two variables. A linear equation in two variables, let's say x and y, can be written in the form ax plus by is equal to c for a, b, and c real numbers. So what's great about these are what's called first degree equations. So these are first degree. You can tell that there's no higher order terms like x squared or x cubed. So equations. And this is also called standard form of a linear equation. So this is the standard form, it's a first degree equation. So for example, x is equal to 0 is linear, this is a linear equation. X minus 2y is equal to 3 is a linear equation. But x minus y squared is equal to 1 is not a linear equation. So linear equations define lines in two variables. So they're planar lines. And so the entire purpose of this lesson here is to be able to graph a line. So given a linear equation, construct its graph. In order to do so, we'll need to be able to find points on the line to be able to graph. So to get there, we need to solve some equations. In order to do so, we need to talk about equivalent equations. Two equations are said to be equivalent equations if they have the same sets of solutions. So for example, x plus 1 is equal to 1 is equivalent to x is equal to 0. Those have the same solution sets. If you subtract 1 from both sides of x plus 1 is equal to 1, you'll obtain the equation x is equal to 0. Those have the same solution sets. Just like x is equal to y is equivalent to x minus y is equal to 0. You subtract y, which is a real number. It's a variable, but it represents a real number. So subtracting it from both sides, you'll see that these two things are equivalent. The reason why we can add and subtract, in fact we can multiply, is because there's a small theorem going on here. The addition and multiplicative properties of equality. So if you have a, b, and c real or complex numbers, then a is equal to b is equivalent to the equation a plus c is equal to b plus c. So for example, with a here, if you have x plus 2 is equal to y, this is equivalent to x is equal to y minus 2. You subtract 2 from both sides. The intermediate step here would be x plus 2 minus 2 is equal to y minus 2. And then you'll see that these two things collapse down to 0. We're going to have plus 2 and minus 2. So you can get some equivalencies going on there. The second one is as long as your number is not 0, then a is equal to b is equivalent to c times a is equal to c times b. And so what you see here is, say you have a 1/2 y is equal to 2x plus 1. And you want to get rid of that 1/2 there. So now this is how we typically do it. We would write the equivalent equations going down. So we would multiply by 2 on both sides of the equation. So here you have a 1/2 y, and then here you have a 2x plus 1. And I'm using parentheses to denote multiplication. And so this one will give us that y is equal to, because you have a 2 times a half, you have y, is equal to 2 times 2, which is 4x, then 2 times 1 gives us a 2x. So these three are equivalent equations. And so that's the point here, is that we'll want to find equivalent equations. So how does this help us finding lines? So when we write an equation of a line, say we want to plot the line x minus 2y is equal to 4. In order to plot the line, we need to find 2 points. And so how do we do so? Well, any points may work. So what I'm going to do is I'm going to choose a value for x. So I'm going to say choose x is equal to, say, 1. So choosing this, we can plug it into our equation here, and then we get 1 minus 2y is equal to 4. So with this case here, I set x is equal to 1. Now I'm going to try to find the associated y value. So using what we talked about before, I'm going to subtract 1 from both sides. So I'm going to subtract 1. And then we'll get minus 2y is equal to 3. Multiplying both sides by a negative 1/2. Put an extra parenthesis there. We will get y is equal to minus 3/2. So the corresponding point here is 1 comma minus 3 over 2. So if we go to our graph here, at the value 1, we're down here at negative 3/2. So that's our point. To get a second point, you can just choose another value. So for instance, I'm going to choose y is equal to 0 in our equation. So this one will give us x minus 2 times 0 is equal to 4, which 2 times 0 is just 0, so this is just x is equal to 4. So the corresponding point is 4 comma 0. Well, that's a nice point. It's much nicer than the fraction we just got, which happens. So in this case here, we go to the x value of 4 and y value of 0, which is out here, and then we have our 2 points. Once you get the 2 points, you play connect the dots. And there we have it. So now we have the plot of the line x minus 2y is equal to 4, here denoted in blue on our graph.